Now let us look at how to build for an UML. Okay, so which we call it as a user mode Linux. I don't know whether I've stressed upon this before. Okay, so user mode Linux is nothing but running a Linux kernel as an application. Okay, so where you will get a feature of a Linux, but running as an application. That is one of the architecture what your Linux kernel supports. It supports a kind of an architecture called UML where you can run an Linux kernel as an application, and whatever you can do with the Linux kernel, you can do everything with this UML. But only thing is, it will be running as an application on the current host. Wherever you're running, right? It's something like I can assume this, it's not a full virtualization also. I will not tell it's a pure virtualization, but we can assume this is something like your VMware or other things running a real Linux kernel, something like that you can assume, but it will be running completely in the Linux space. So all the architecture stuffs, okay, is simulated via the host mechanisms. For example, the timer is simulated via the signals, okay, alarms and other things, okay. Interrupt are simulated via your signals, okay. So like that, all the mechanisms are fully simulated in this application mechanism. So this mechanism is nothing but your UML, okay. So why UML is useful is because it will be running as an application on the current subsystem. If you want, you can kill it very easily without having any impact. And debugging is also very simple because you have to debug using simple GDB interface. Connect just like an application, and you can start debugging. That is one of the main advantage of this UML subsystem. Okay. So now let us understand how exactly you have to build the UML itself. The step is very simple. First, you have to download the BusyBox. You have to extract the BusyBox, and you have to create the configuration, the dev configuration, and you have to go to the menu config, select the static, and once you have done this, your BusyBox will be available. Okay, so let me do the steps for you for time being. So let me go to UML. Let me try to delete this BusyBox. So let me extract BusyBox. So I'll go to this BusyBox. Then I will tell make dev config arc is equal to UM. So this is the architecture what we have to use. For example, if you come here, you'll find a new architecture called UM. UM is for user mode Linux. Okay. So UML, basically what we call it as. You have to tell this.
UM means
Wow.
user
User mode Linux means
user.
user mode Linux.
Okay.
UM stands for user mode actually. Okay. Means you're running a Linux kernel in the user mode. That is what it means. Yeah. So now make menu config arc is equal to UM again. So once you do this, you will get the settings. So the main part what I have to do is I have to build a static, and then in the network utilities I have to disable TC. Then things will work fine. So once you see this,
We need to disable, sir.
sorry,
I,
sorry, I didn't get you. What were you asking?
why we need to disable TC?
TC is not working with the current latest compiler, whatever I've installed with 24.04 Ubuntu. That's the reason we disable it. But this is a workaround only. Okay, really speaking, we should not disable it, but the compilation fails. For that reason, we disable it. Okay. So any of the TC utility, we don't use it. So that is the reason it doesn't make any impact actually. Now we have to tell make arc is equal to UM. So once you do it, it will compile and then it will generate the necessary parts actually. Just let me show that. Just give me a second. Okay. So now it will be there almost. Okay. So now almost it will compile. It will take another 1 or 2 minutes and it will compile the BusyBox at least. Linux kernel, I will just tell you the steps. You can try it out because Linux kernel would take a lot of time to compile. So that's the reason. But I'll mention you the steps, what is required, or using the current infrastructure only, I'll build again to show you people what exactly it would look like. Okay. So just give me a second. It is almost done. So BusyBox building will happen very fast because it doesn't have so much of binary to compile. It will happen very fast. Okay. So networking utilities, it is compiling. But after that, once it is done, we are almost there. Hmm. Yeah, I think everything is there. Mhm. Yeah. Yeah, most of the things are done now. Compilation is done. Then I can tell make install arc is equal to It will install and set up everything actually. Okay, so now the BusyBox is set up properly. Okay, so now the BusyBox is there. Now, if you go to this Linux kernel, right? So what you have to do is you have to tell make def config arc is equal to It's very important. Okay, then after that, you have to tell make menu config arc is equal to to get the configuration. Just to make see, a lot of UML features has come into picture. UML network driver, UML specific options. So architecture itself is based on UML. That all things you can check out here. Okay, so now the necessary configuration is there in place. So once
So
that
sir,
is there,
here arc we are giving as So if how we will be differentiating whether it is for ARM or for
no, it
x86
is
or that
always UML is meant for x86 host only most of the times.
only x86. Okay.
Ah. So that is the reason whenever you even you simulate also, right? It will be targeting. That is the reason it built for x86 only. Okay, it doesn't
Okay.
support many much architectures. Most of the time it will work on x86 underscore 64 only. Okay,
Okay.
so that is the reason it's fully integrated with x86 underscore 64 bit host. So if you want to try this on ARM and other things, no, most of the things will happen. Configuration will happen, but when you try to compile it, no, it will start failing because all the source code is based on x86 underscore 64. Okay.
Okay. Yeah.
Yeah. So now after that, once you have done, you have to compile it, make arc is equal to Most probably the compilation will happen much faster because I've already compiled it actually. So it should not take much time. I hope, see, it is almost, let us just to see, see, it is built the VM Linux. Okay, so the VM Linux is run. Just to prove that it is working fine, you just run this VM Linux. Normal, the architecture, if you try to run, it will fail. See, if you run, see, the Linux kernel started here. The complete Linux kernel started. It is doing all those things, is setting up all the inodes, entry, data entry, mount point, network also it's set up, UDP also is set up, all the things. But it failed because it was not able to mount rootfs. Because the Linux kernel is fully dependent on rootfs. The rootfs is missing. That is the reason it was not able to start, as you can see here. Okay, so now this is the proof telling that the Linux kernel is starting, but it didn't find the rootfs. This it would happen the same way if you try the same thing on your target machine, and if you don't pass a rootfs, you will get the same error message. The same error message is coming. So this is to indicate that Linux kernel is as such is working, but moment I direct it with the correct rootfs, it will start working. That is the main thing which I want to point. Now, since the UML is run, and then we have so basically the rootfs is already there now. Okay. So let me just to tell you one thing. So the UML kernel is also there now. Okay, so UML image also I have built. Now I have to just run. But before that, I have to create a rootfs because whatever is there in BusyBox is not a complete rootfs. We need a full rootfs. So we have to set up a full rootfs. The steps for setting the full rootfs is very simple. I will just delete this current rootfs just for you people understanding. You need to delete it. So there is some folder called rootfs base, which I normally pass. this contains the necessary script. The BusyBox should be supported by necessary script. What are the script? If you remember from BusyBox init, I talked about init tab, RC scripts, all those scripts are very much required. If that is not there, then your BusyBox will not work effectively. So that particular script is I've created and I've placed it in rootfs base.tar.gz. I'll just show you. So if you do this, and if you go to this rootfs base, let me show you the tree structure to see what exactly I've stored. So it has nothing. Basically, it has some fstab file that is required for mounting. Currently, I'm not using any fstab options. Init tab, which your BusyBox init would need init tab. I put an init tab. From init tab, I mentioned the configurations. The main system configuration script is RCS. So init tab and RCS is there, and some folders. So the moment my rootfs comes up, right, I have to see proc, temp, var, all those things is required. So I'm creating a folder for that. And your rootfs needs few device files like console, fb0, null, ram0, because I'm not mounting proc dev temp fs now. Okay, I'm not mounting. If you want, you can mount it. It will automatically come up, but we need the specific console specific files. So I've
Sir,
created device files here, few device files. Yeah, tell me.
in rootfs, what are the folders are mandatory and which are all?
You need a proc because you need to, whenever you want to run an application, right, you would need procfs, proc file system. So that is the reason I've created an empty folder called proc, but I will mount it when I run it. Okay. Temp, you need some temp folders to create some temp fs. So I've created temp. Then after that, home directory, if you have any users present, right, you need a home directory. Mount, if you want to mounting something, mount is required. Dev is very much required. And configuration file called etc. This is the necessary minimal folders what you would need. In this, I can remove home, not required. MNT I can remove, I'm not mounting anything. Temp I can remove because I do not mounting any temp fs. If I create any temp fs, I have to create the, I have this temp folder. Var is also not required because I'm not creating any temporary paths. So that is the reason this, other than this, dev is very much required. etc is very much, fstab also I can remove because I'm not using fstab now. I'm using only RCS and init tab in my startup. Okay. So home you can delete it, you don't need. MNT you can delete, at least in my setup I don't need. Proc I need because the proc fs is very much required for starting an applications. Temp also if you want to can remove, var also you can remove, but other things are very important actually.
Sir, sysfs not required.
I'm not mounting sysfs, so I don't need sysfs now.
Okay.
See if
This
you want.
init tab and RCS is what?
Init tab is here. If you remember from our BusyBox init, whatever I talked, right? The first file configuration file which your BusyBox init will look for is init tab. It will have all the configurations.
Okay, okay.
If you remember, I was talking about the configuration, right? Sysinit, and there will be something called ask first. A lot of options will be there, right? That is something what I will fill here. So if you look at here, what exactly at least I have created in my init tab, see, this is what I've created. What should happen on restart? Control Alt Delete if somebody presses what should happen. Shutdown what should happen. Sysinit what should happen. This is the system initialization file. And that is present. RCS contains that. So if you look at this RCS, what is there in RCS? Just give me a second. It is there in init.d. RCS. If you look at here, it has something. Say I'm mounting the procfs here. I'm telling boot time. I'm printing the boot uptime. And then I'm starting the shell. This is the only thing I'm doing. Got it?
Yeah.
Okay, so now I have all the necessary things actually. Okay, so now this rootfs base is very much required, but this is not fully complete because it needs all the binaries. So what I will do is I will create rootfs. I'll go to this rootfs folder. I'll copy the content of rootfs base to this. Okay, then after that, I'll copy the content of BusyBox underscore install. So now if you look at here, the complete rootfs is ready now. But in this case, I'm not compressing, and after that, I'm not doing anything because it's running as an application. I'm not loading the real init RAM disk or that also I can do it, but I want to use the host file system. The one property of UML is it can access the host file system directly because since it is running as an application, right, and access all the host things. That is the reason I don't need anything. Okay.